Hello, my name is Stephen Gottlieb. I made up the Physics 1 video. At this point, I would just love for you to sit back, view a sample demonstration which I made up. That way you get to see a little bit of my teaching style. Then we get right into it. Behind me, I have a problem written down. It's a very classic problem. It goes on to say that two trains are 60 miles apart and they are heading towards one another on a single track. Each train is traveling 30 miles an hour. So if you have train 1 over here, and you have train 2 right here, and the total distance is 60 miles, well, and each train goes 30 miles an hour, train 1 is going this way, train 2 is going that way. In 1 hour, train 1 will have gone 30 miles, and train 2 would have gone 30 miles, meaning that the trains are going to collide. But there's this bird. A bird keeps flying from one train to the other at 60 miles an hour. So, the bird is going twice as fast as the train. Okay, so for argument's sake, let's say the bird is right here. So now, let's look at this 60 miles for a moment. The bird is going to, quote, stop. We're going to stop the clock when this bird and this train meet. Since the bird goes twice as far than the train, 2 plus 1 is 3. I'm going to divide this 60 miles into 3 equal parts. 20 miles, 20 miles, 20 miles. Train 2, let's suppose it goes 20 miles. Okay? Each of these are 20 miles. Train 2 goes 20 miles, and the bird goes twice as far. The bird goes 40 miles. 20 plus 20. Oh, so the bird is right here. Train 2 is now here. The bird is here. And train 1, just like train 2 went 20 miles, train 1 went 20 miles. Train 1. So this is the picture after the bird made one trip. When a bird goes from one train and it meets the other train, we'll call that a trip. Now the bird is here and it's going to go and meet with train 1. Well, this 20 miles, or whatever the mileage is, just for whatever the mileage is between the two trains, it gets split up into 3 equal pieces. Notice that this is 60 miles and this is 60 over 3 miles. Now, what happened is the 60 over 3 miles gets divided by 3. You get 60 over 9, 60 over 9, which is 3 squared, 60 over 9, or 3 squared. Train 1, which is right here, goes to here. Train 2, which used to be right here, now goes here. And the bird, which is on the right side, it goes 2 distances. It goes right here. That's why we stop the picture. What you need to keep seeing is that 1/3 of the distance remains. 60 is the same as 60 over 1, which is 3 to the 0. 60 over 3 is the same as 60 over 3 to the 1. And then the distance between the two trains after the bird meets one of the trains, going to be 60 over 3 squared. And then it's going to be 60 over 3 cubed, etc. Now I should have made this comment a little bit earlier. We're going to assume, this is a physics problem, there's some things you have to assume, especially when it's not stated, nothing is stated about something. Nothing is mentioned about how quickly the bird turns around. It just says the bird keeps flying at 60 miles an hour. That is, when this bird is going this direction and it reaches train 2, it turns around and it goes back 60 miles an hour at the rate of 60 miles an hour. It's going 60 miles an hour this way and then 60 miles an hour that way. We're going to assume it never stopped. It didn't slow down and then turn around. It's going 60, 60, 60 and then 60, 60 the other way. It never stops. The other thing is, as you can see, this distance is getting smaller and smaller and smaller and smaller. The distance between the trains. Now, if this is one train and this is another train, you may say, wait a minute. The bird is that big. It can't even fit between the trains. No. The bird, second assumption is the bird will never get squashed. It can turn around instantly and it can never get squashed. All we're going to do is count, we want to count the number of times the bird goes from one train to the next train. And we know that this ends when the distance is 0. Now again, no matter what happens, this experiment ends in 1 hour. Because train 1 will go 30 miles in 1 hour. Train 2 will go 30 miles in an hour. Since the trains are 60 miles apart, they will collide in 1 hour. And the question is, how many trips does the bird make? Well, when the distance is 60 over 3 to the 0, the number of trips, so let t be the number of trips. The number of trips made is 0. Because we didn't start anything. The bird is here, and we start the clock. And the instant we start the timer, the clock, the trains are moving 30 miles an hour. And the bird is flying 60 miles an hour. Okay. So at the start, the bird is on the left. It didn't make any trips. Then sometime later, train 2 and train 1, they meet. Sorry, train 2 and the bird meet. They meet right here. The number of trips the bird made is 1. And the distance between the two trains is 60 over 3 to the 1. Now the bird is over here. Train 1 is still going 30 miles an hour. The bird is coming back at 60 miles an hour. They're going to meet. They meet right here. That's another trip. Number of trips is 2. And the distance between the two trains is 60 over 3 squared. Now, this is going to end when the distance is 0. So, like if I had down here, the distance is 0, I would look to see what number it has right there, and I would say, I know the answer. Number of trips the bird makes is that number. This is what we're looking for. This is what we're looking for. Now, in general, after the nth trip, the distance between the two trains is 60 over 3 to the n. And what I notice is, what do all of these have in common? The answer is, they both have 60 over 3. They all have 60 over 3. What's changing? The answer is the power of the 3. 0, 1, 2, 3, 4. oh, wait a minute. This power is always equal to the number of trips made. 1 trip, 60 over 3 to the 1. 2 trips, the power of 3 is 2. N trips, the power of 3 is n. Now, we need to know when that distance is going to be 0. And here's an amazing thing. The limit as n approaches infinity of 60 over 3 to the n. This is 0. This fraction, if n gets bigger and bigger and bigger and bigger, 100 billion, 300 billion, a gazillion, you divide 60 by 3 to a really large number, which means you keep dividing 60 by 3, and then 3 again, and 3 again, and 3 again. It'll never be 0. It's at infinity it's going to be 0. That is, the number of trips that the bird makes will be infinite. When the two trains are really close to one another, the bird is just going to be making, I didn't draw that too well, the bird is going to be making a lot of trips. The bird is going to be making a lot of trips. And down here, it's going to make an infinite number of trips. So here's a great physics problem. How many trips does the bird make? The answer is infinite. The reason is, what they're just asking you to do in this problem is they're saying, okay, you have a distance of 60. Every time you walk 1/3 of the distance, clap your hands, or let a bird fly from one train to another. Divide this by 3. Clap your hands. Divide this distance by 3. That is, when you've walked 60 over 27ths of the distance, clap your hand. 60 over 3 to the 4th. 60 over 3 to the 5th. That's the remaining distance. Well, you're going to be clapping your hands an infinite number of times before you walk the 60 miles or the 60 feet. Classic problem is if you have some distance, like walk from here to here. Walk from where you are now to your bedroom. Okay, it's not going to take long, it'll take seconds, half a minute maybe. And when you walk halfway, clap your hands. And then when you walk halfway of the remaining distance, that is from here to here, clap your hands. Be halfway of the remaining distance, which is here, clap your hands. Here. Now, what's happening is when you get towards the room that you want to finish at, you're going to be clapping your hands a lot. Okay, this was half. Our example was thirds. Classic physics problems. Impress your physics teacher by knowing this problem and how to solve it. This completes the sample demonstration. Hope you learned this classic physics problem. Hope you enjoyed it. Most of all, I wish you great success in your Physics 1 course, and thank you very much for watching my video to the end.